Well, welcome to Soil Judging 2020, the COVID edition crazy world. So we're just really glad that you're here and you made it today to the soil judging contest. We're just really glad that we've had this opportunity to actually follow through with an activity that everybody can get outside and get involved with. So if you've judged before, hopefully the new process wasn't too crazy. But if you haven't judged before, you don't know any different. So maybe next year it may be the same, it may be different. But that's just kind of the way things work, is you just got to roll with the punches. So we're going to go ahead and we're going to do the critique today. And we are going to, hopefully you'll be able to remember some of the things that we saw in the pit. So, and hopefully everybody and maybe would have grabbed some samples of some of the really unique materials that we had out here in the soils pits today. So this is hole number 1. We judged this as a Homesite hole. The parent material on this particular pit, we told you to judge the parent material between 20 and about 40 inches. So that's getting down here in this lighter gray silty material. But the material that's up above it is this really blocky material. This is a really heavy material, heavy clay. And then we have some really silty tip material down below it with a fairly distinct boundary somewhere around the 37 to 8 inch layer. So the parent material on this particular pit is what we would call an outwash of lacustrine deposit. This is more of the lacustrine side of the parent materials, just because we have the super heavy clay textures here in the subsoil. Now just remember, when we talk about stratification in the pit, it doesn't necessarily have to be within the yardsticks when you're looking for these materials, and it doesn't necessarily have to be above 40 inches either. It just says in the book that anywhere in the pit you can look for these differing contrasting textures in the soil profile. So not always just between the yardsticks, but you can look around other places. The slope on this one was 3 to 6%. So the slope stakes were here to the north of us. The landform, because it was 3 to 6% and the parent material coupled together, make this an outwash or lacustrine hill slope. The surface color on this one was brownish. And you're probably going to remember that you had to go through a lot of water today. So, but that's pretty evident that it's fairly brown. Of course, we did the soil textures and the colors out of the buckets today. So what we got in the bucket is a little more indicative of the materials we had. Get my color book out here. Give it a little crush. And then we have a pretty decent 10YR 4.3. I hope everybody likes my book upside down. So kind of a 4.3 or a 4.4. There's a little bit of influence of some of the erosion that has been deposited from higher up in the hill. So we do have a little bit of overwash or overwash or recent deposition influence here. So the surface color is brownish. The erosion here, the previous erosion, is none to slight. Once again, we're looking at that. How much of our original surface do we have that's left in the upper 8 inches? And here, because we've got a little bit of deposition from higher up on the hill slope, we've got probably closer to maybe 9 or 10 before it starts getting into this blockier structure of our subsoil here. So our topsoil here is about 9 inches thick, so that makes this none to slight erosion. The surface texture, as we said before, we did those out of buckets this time, which would be very similar to the way the state contest is run. If you've been to the state contest, the textures are done out of buckets also. The surface texture here is medium. It's a silt loam. Like I said, this is very, very, very prominent texture here in the southern part of the state, just because of our lust cap that we have that's either in place or been rearranged by wind or water. The subsoil, once again, was in the bucket, but it pretty much came from this material here, this really blocky structure that you see in the subsoil. It takes a little bit to get it worked up, just because it's fairly dried out, but hopefully we put some water in the buckets for you, so hopefully it's a little softer tomorrow. The subsoil texture here was moderately clayey, so it's once again a heavy silty clay loam. Natural soil drainage. This one was a little bit of a tough call, even for us. So when it's tough for us, we just try to make it easier on you novices. So we just gave it to you on the card today. But the natural soil drainage that we said in this particular pit today, we called it moderately well drained. So in our 10 to 18 inch layer, which is our first diagnostic zone that we look at, we don't see any gray colors up in here at all. So since we didn't see any gray colors in our 10 to 18 inch layer below our brown surface, then we don't have, that throws it out of poorly or somewhat poorly drained. So our next diagnostic zone that we're looking at drainage is between 18 to 30. So we're looking in this layer here, in this horizon here, for dirt gray drainage models and things like that. So we see some of them, there's a little bit of them here. Some of our clay films are kind of gray. We see some really nice ones right here around the 27, 28 inch layer. So we got some gray colors coming in, but just because they weren't super consistent between the 5 pits, we went ahead and told you and gave it to you on the card that this is a moderately well drained profile. The white material, the real pale material that you see, is what we are actually carbonates. So if we had had a little bit of acid, weak acid, we could have put that on there and those would have really fizzed or reacted. So that we did go ahead and put that on the site cards today, that we do have some carbonates here in the profile, but that's a good characteristic that we see in a lot of our lacustrine soils, are these carbonates that you see reprecipitating out of the soil profile. So, but those, once again, those don't consider drainage, because when you put a little bit of water on them, they're kind of like silk coats in our frangipans. They kind of silt and they just kind of fade away, and then you see the true colors back in behind them. So the limiting layer on this particular pit came out as none. There is no limiting layer here in the profile. This is just one of those things where we actually have carbonates, but they don't equate out to maybe being a limiting layer in this particular situation. So that's pretty much it. So here's our silty material. That's probably has some pretty high carbonate in it also. And that is pit number 1.